So, hi guys, today we're going to cover an algorithm which is called the digit extraction algorithm. This algorithm will be helpful for us to solve many math related problems in the future. So, let's quickly get started with it. So, for example, let's say we have a number called 138472. Now, this number is an integer, okay? And somehow you need to extract each and every digit out of this number without converting it into string. Hear me out. You need to extract every digit out of this number, keeping it as an integer without converting it to a string. So let's see how we can do that. So the first thing that comes to your mind when you look at this number is you somehow need to separate this units digit away from all of these numbers, right? You need to somehow separate this from 13847. So what you can do in this case is you can take a modulo of this number with 10. The modulo of any number with 10 would give you the units digit. Now once you have this units digit, you can just print this as you get it, and now you have this number. So somehow you need to discard this number and make your number like this, and then again do a modulo 10 to get this 7 here. Now let's see how we can do that. Okay, so if you do modulo 10 you get the units digit, but if you do integer division 138472, integer division by 10, then your number becomes 13847. Now once your number is 13847, you can again say 13847 modulo 10, which would give you uh, the units digit again, which is 7 in this case, and then again you can say 13847 integer division by 10, which would give you 1384. Now again you would take 1384 modulo 10, which would give you 4, and then again you would do 1384 integer division 10, then you get 138, and similarly you repeat the process. Now what happens when you repeat the process? You say 138 modulo 10 equals to 8, and 138 integer division 10 becomes 13. Okay, then you say 13 modulo 10, which becomes 3, and 13 integer division by 10, which becomes 1. Now again you say 1 modulo 10, which would give you 1, and 1 integer division by 10, which would give you 0. So here we are observing a pattern. First we are doing modulo 10, then integer division 10, modulo 10, integer division 10, modulo 10, integer division 10, until your original number becomes 0. Okay, until your original number becomes 0. So how can we express this in code? Let's see how we can express this in code. So we are going to call our function extract digits, which would return nothing. We just want to print the digits. So we would say extract digits. This would take a parameter which would be an integer, which is the number of which you need to extract the digits. Then we would say while our number n is greater than 0, we would say integer digit equals to n modulo 10, and then we would just print out this digit. So let's say system dot out dot println digit, then we would uh, we would do the integer division step. Would say n equals to n integer division by 10. This in Java by default leads to integer division. So yeah, so that's all. So now let's quickly discuss the time complexity of this algorithm. So we have this while loop running. Now this while loop will run as many number of times as there are number of digits in the integer n. Okay, so this loop runs number of digits number of digits number of times and this number of digits in n. So in mathematics there's a whole big proof behind this, but we have number of digits for a number n equal to floor of log n base 10 plus 1. Okay, so this is a theorem in mathematics. We have a big proof behind this. Let's not go there. So you just need to remember this, and as you can see that the while loop is directly proportional to this log of n base 10. So we can say that the time complexity for this algorithm is O of log n base 10, and the space complexity would be, let's see the code once more. So no matter how big the n, we would have this one integer as extra space. So it is occupying constant space. The amount of space occupied does not depend on the input, which is n in this case. So we can say that the space complexity for this algorithm is O of 1. Yeah, so that's it. Now let's run this code in the editor and see what the output is. So I have the same code written in my code editor, and I have taken the example of 138472. Now let's run this and check the output. So as you can see, first the digit 2 is extracted, then the digit 7 is extracted, then 4 is extracted, then 8, then 3, and at last 1 is printed. So this was a very important algorithm. We are going to use this technique a lot in our future problems. So thanks for watching, and see you guys in the next video.